In order for our sample size to be large enough to ensure that the central limit theorem will hold and allow us to use the normal distribution for inference for p, we need to have that n times p is at least 10 and n times 1 minus p is at least 10. If the sample is not large enough, we would not be using this central limit theorem based stuff to do inference for p and would need to do what we were doing in chapter 3, chapter 4 with bootstrapping or randomization tests. So if we have a sample of size 10 in part A with a population proportion of p equal 0.2, the question is the central limit theorem going to hold? And if not, how big would our sample need to be for it to work? Notice that if we check n times p here, we get 10 times 0.2, which is only 2. So already we can see that this, I'll exit off, is not true as far as being at least 10. How would we get this to be at least 10? I need n times 0.2 to be equal to or greater than 10, and if we solve this for n, we will get that we need n of at least 50. So once we hit 50, we'd be okay with this value of 0.2. In part B, we have a sample of size 100, and p is 0.6. If we check n times p, we will get a value of 60. That is okay. We have to check both of these. This is an and statement. So if we check 100 times 1 minus 0.6, or that would be 100 times 0.4, we'll get 40, and that also checks out. So we are good in this one. Let me fill this 15 up here. So we're asked then to fill in where would we be centered. We'd be centered at the value of p, so 0.6 would be the mean here. And then the standard error is equal to the square root of p times 1 minus p over n. And this is going to give you a value of 0.049. So we'd have a center at 0.6, which is p, and then the standard error is 0.049. In the last one, we have 40 and 0.9. If we check n times p, we will get 36. That checks out, greater than or equal to 10. If we check n times 1 minus p, we get 40 times 0.1, which is only 4. This one does not check out. So how would we bump this up to be at least 10? We notice that this here is 0.1. So we need some number n times 0.1 to give us at least 10. And so if we solve that value for n, we will find that this is going to imply that n needs to be at least 100 for the central limit theorem to hold.